What if your brain wasn't the smartest brain in the room anymore? Don't worry, your cat hasn't secretly mastered calculus, and your toaster isn't plotting world domination. Although it does feel oddly personal when it only burns your slice of bread, the real challenger isn't your pets or your kitchen appliances. It's artificial intelligence powered by neural networks, systems inspired by the human brain that can write essays, paint portraits, diagnose illnesses, and even crack a joke or two. Sometimes they're so good at it that they rival the very humans who created them. Welcome to 2025, a time when artificial neurons are taking center stage, while human neurons are just trying to keep up. Neural networks explained, from sci-fi to everyday reality. In the early days of machine learning, teaching a computer felt like babysitting a stubborn toddler. You had to spoon-feed instructions, telling it exactly what to look for. Edges in a photo, keywords in a sentence, or signals in a dataset. Then neural networks arrived and changed everything. They essentially said, "Relax, human, I'll figure it out myself." Instead of micromanaging, we now had machines teaching themselves, uncovering patterns and features automatically, and they became incredibly good at it. By 2025, neural networks power almost every aspect of our daily lives. Self-driving cars that see and react to traffic faster than most humans. Language translators that make communication across borders effortless. Creative AIs like DALL that generate stunning art. Chatbots like ChatGPT that can write, explain, and converse naturally. Game-playing AIs like AlphaGo that defeat world champions. They're no longer sci-fi. They're the invisible intelligence woven into our apps, tools, and experiences. Layers of intelligence, the sandwich analogy. To understand neural networks, picture a gourmet sandwich. The input layer is the bread, the plain starting point where raw data enters, like pixels from an image, words in a sentence, or audio signals from speech. The hidden layers are the fillings, the delicious middle where the real transformation happens. Each layer extracts and refines patterns. Early layers detect edges, middle layers recognize shapes, and deeper layers identify objects such as a cat, a car, or a ball. Finally, the output layer is the last bite. It delivers the answer, 98% cat, 2% dog, or next word, pizza. The taller the sandwich, the more hidden layers, the more abstract and powerful the learning. Shallow networks with only one or two hidden layers can handle simple tasks like spam detection. Deep networks with dozens, hundreds, or even thousands of layers tackle complex jobs like natural language processing, autonomous driving, or image generation. By 2025, we now have experimental models with trillions of parameters and thousands of layers. Systems that produce outputs so sophisticated they feel less like machine predictions and more like imagination. Inside the network, neurons, weights, and gatekeepers. So what's happening inside this sandwich? At the core are artificial neurons. Each one takes input data, multiplies it by weights, which determine importance, adds a bias, a small adjustment, passes the result through an activation function, which decides whether the signal fires to the next layer. Think of it like this. Weights are volume knobs. If number of bedrooms matters more than paint color when predicting house prices, the network turns up the weight for bedrooms and down for paint. Activation functions are bouncers at a club. They decide which signals get through. For years, simple activation functions like sigmoid or tan got the job done. But then ReLU, rectified linear unit, took over. It was fast, simple, and effective. Pass positive signals, block negatives. Today, advanced functions like Swish and GLU dominate massive AI models, improving accuracy and stability. If this feels abstract, imagine a team meeting. Everyone shares input, but some opinions carry more weight. The leader, the activation function, decides whether the combined support is strong enough to move forward. That's exactly how neurons collaborate inside a network. DIY neural networks. Theory is fascinating, but let's make it real. Imagine you want to build a basic movie recommender. Ask 3 yes, no, no questions. Do you like action? Do you prefer long movies? Do you watch in English? Code answers as 1, yes, or 0, no. Multiply them by weights and add them up. If the score is high, recommend Mad Max, Fury Road. If not, suggest La La Land. Add feedback. Did you like it? And adjust the weights. Over time, the system learns. Congratulations, you've just built the baby cousin of Netflix. Or for something visual, try Google's Teachable Machine. Upload photos of pizza slices, label them pepperoni, veggie, or Hawaiian, and let it train. Suddenly, your webcam can classify dinner. By 2020, tools like these have expanded dramatically. Teachers build interactive lessons. Artists design installations that respond to sound or movement. Small businesses automate inventory with a phone camera. Neural networks have gone from labs to classrooms, kitchens, and living rooms. The drama of depth, bigger, faster, stranger. The deeper the network, the stranger and more powerful it gets. Early layers, edges and textures, mid layers, shapes and objects, deep layers. That's a cat doing yoga on a spaceship. By 2025, we've gone from GPT-4, 96 layers, billions of parameters, to experimental mega models with thousands of layers and trillions of parameters. These systems generate not just text and images, but also music, video, and immersive simulations. But here's the catch. Bigger isn't always better. These giants consume enormous amounts of electricity and water, raising both economic and environmental concerns. Training a single massive AI model can emit more carbon than multiple cars over their lifetime. That's why researchers are now championing green AI, focusing on pruning, distilling, and compressing networks to reduce waste while maintaining performance. The challenge is clear. Find the sweet spot where intelligence, efficiency, and ethics align. Neural networks for everyone. Perhaps the most exciting shift is accessibility. Neural networks are no longer locked behind PhD degrees or billion-dollar labs. A high school student can build a facial expression detector on a laptop. A teacher can design a math quiz that responds to student gestures. An artist can make visuals that react to movement during a live performance. Even grandparents can build a simple model that claps every time they smile into a webcam. And beyond fun, the applications are life-changing. Healthcare. Neural networks detect cancer and X-rays earlier and more accurately than ever. Finance. Banks spot fraud in real time. Entertainment. AI creates hyper-realistic videos and personalizes streaming recommendations. Daily life. Smarter search engines. Assistants that remember context across months. And apps that feel like digital companions. Neural networks have evolved from humble 1960s perceptrons into trillion-parameter giants shaping art, medicine, and culture. They aren't conscious, but they're redefining intelligence as we know it. Neural networks don't need magic, they need data, feedback, and time. The real question isn't whether they'll change the world, they already have. The question is, will we guide them responsibly or let them guide us? They're powerful, they're everywhere, and they're here to stay. Loved what you learned today? Let's take your AI journey further. Click the link in the pinned comment to get your copy of AI Unlocked on Amazon. Join the AI Unlocked online course, packed with video lessons, real-world examples, and hands-on strategies to future-proof your skills. Subscribe now and unlock early bird discounts, exclusive AI cheat sheets, behind-the-scenes content, and community access. Don't forget to like, subscribe, and hit the bell so you never miss a breakthrough. Together, let's unlock the future. One video, one idea at a time.